Hey guys, up until right now, since sixth grade, you've been solving equations and your answers have all been one solution for each equation. So for example, x equals 4 or x equals 5. Well, that's not always the case. So some equations, when you solve them, you find out that there is no solution to that equation. And other equations have an infinite number of solutions. In other words, any real number you plug in for your variable would make the equation true. So those are the types of problems we're going to look at today. So you guys have been practicing solving 1- and 2-step equations. So let's just review those directions. The first thing you do is if you see a set of parentheses and you need to use the distributive property, you would do that first. Next thing you do is combine like terms. Following that, you would get your variables together on one side of the equal sign. Then you would undo addition and subtraction. And finally, the last step would be to undo multiplication and division. So those are the steps in solving equations. So let's look at this first example. So I have x's on both sides of the equal sign. So I am going to get my x's together. I can find my mouse. My goodness. Oh, I was writing on my screen over here. Oh, there we go. I don't know why I can't see my mouse. There it is. All right, so first step is after we draw our line, let's pretend I can draw a straight line. Oh, that was terrible. Anyway, we're gonna get these x's together. So how would I cancel out a positive 4x? Why am I writing like this? But you know what? Let's reverse. Oh my goodness. Okay. Let's try this one more time. Okay. So let's get our x's together. So we're going to subtract 4x from both sides. That's a little better, not much. All right. Where'd my line go? Oh my goodness, this board. All right, so what happens? So 4x minus 4x is 0. 4x minus 4x is 0. So what are we left with? We're left with 18 is equal to 5. Well, is that true? If someone owes you $18, would you accept 5 and say, okay, we're good? No, you would not. So those numbers are not the same. So in other words, there is no solution to this equation. There's no number I could plug in for x and make this equation true. Oh, so they're going to do it too. So they're going to subtract 4x from both sides of the equal sign. And they said, oh, well, does 18 equal 5? No, it doesn't. Therefore, this equation has no solution. All right, let's look at another one. Now this one, after we draw our line, our squiggly, oh, that's pretty, isn't it? All right, so let's combine like terms. So we have negative 5x combined with negative 1x. What's negative 5 minus 1? Negative 6x plus 7 is equal to negative 6x plus 2. Well, how am I going to get my x's together? I'm going to add 6x. That's the only way to cancel out a negative term is to add. Well, when I do that, all of my variables cancel, right? That one's gone, that one's gone. What am I left with? 7 equals 2. Is that true? Does 7 equal 2? No, that's not true. Therefore, this equation has no solutions. They're doing the same thing I did. Yep, 7 equals 2. No, it doesn't. No solution. All right, so sometimes, however, we'll find an equation with an infinite number of solutions. So look at the first example, 5x plus 8 is equal to 5x plus 8. Well, do you notice those two expressions match perfectly? 5x plus 8 is equal to 5x plus 8. Well, let's pretend for a second I didn't realize. I don't know why I keep losing my mouse. Do you guys see it? There it is. Oh my goodness. All right, so let's pretend I didn't notice that these two equations matched perfectly. And let's say, okay, well, I want my x's together, so I'm going to subtract 5x from both sides of the equal sign. And when I do that, My x's cancel, correct? So what am I left with? I'm left with 8 is equal to 8. Well, is that true? Does 8 equal 8? Yes, that's true. That means that the solution is all real numbers, or an infinite, you can say infinitely many solutions. Because I could plug in 2 for x's and the equations are true. I could plug in a 10 for x's, this equation will be true. I could plug in negative 100 and I would get a number is equal to the same number on the right side. So an infinite number of solutions. All right, what about the next one here? Let's draw our line. All right, what we're gonna do first? Let's combine like terms. So 3x, and then we have negative 14 minus 2, that's negative 16. On the right side, 8x minus 5x is 3x minus 16. If we got our x's together, we would actually realize that, oh my goodness, everything cancels. Those variables cancel, these variables cancel. What am I left with? I'm left with negative 16 is equal to negative 16. Is that true? Yes, it's true. So we have an infinite number or infinitely many solutions, IMS, infinitely many solutions. All right. Now, some people believe that if they figure out that x is equal to 0, that means there's no solution, but that's not true. You can get an answer of 0. That is a valid answer, okay? For example, let's look at this problem right here. So we're going to draw our line. All right, I got x's on both sides, so I want to get them together. I want to put them on both sides, one side of the equal sign. So I'm going to cancel out my smallest x. Well, 1x is smaller than 5x. So how do you cancel out a positive x? You subtract x from both sides of the equal sign. Subtract x. So what do I have? I have 5x minus 1x is 4x. I'm going to bring everything else down. So now I want x by itself. So how do I get rid of minus 13? Well, the opposite of minus 13 is plus 13. So then I have 4x is equal to 0. I'm not done yet though, because something is still attached to my x. I'm going to right now, x is being multiplied by 4. So what do? I'm actually going to divide by 4. Divide both sides by 4. And am I allowed to divide 0 by a number? I am. If I plug that in my calculator will tell me the real answer is 0. So that's fine. You can get x equals 0, and that is a real solution. So don't let that type of problem trick you, okay? All right, so here are 3 problems right here. I want you guys to pause the video. Well, first, let me tell you what I want you to do. So I want you to pick at least 2 of these. Pick 2 problems, write them down, pause the video. I want you to work them out. Don't just watch me work them out. You need to practice it too. And then come back and check your answers, okay? 2 problems. All right, so let me do this with you. If hopefully you've already done it, right? You've already done this, so you're just checking your answers. So we don't have any like terms on the left side of the equal sign, so we just bring everything down. 4x plus 1x is 5x minus 8. I'm going to add 4x to both sides. Add 4x to both sides. So I end up getting negative 8 is equal to 9x minus 8. Now what do I do to get x by itself? I add 8 to both sides. Well, negative 8 plus 8 is 0 is equal to 9x. When I divide 0 by 9, I get x is equal to 0. Is that a valid answer? Yes, it is. All right, on example 2, if I subtract 3x from both sides, I'm going to end up with negative 7 is equal to 2x minus 7. And now I'm going to add 7 to both sides. So I get 0 is equal to 2x When I divide by 2, that goes away. X is equal to 0 again. And then the bottom one right here, if I'm going to get my x's together, I'm going to add the smaller of the two x's. Negative 7x is smaller than negative 4. All right, so I have, this is gone. I have 1 is equal to negative 4x plus 7x is 3x. Then I'm going to get x by itself, so I need to subtract 16. So I have, oops, 1 minus 16 is negative 15 is equal to 3x. The opposite of multiplying by 3, I divide by 3, so x is equal to negative 5. So I have one solution for all of these. Well, that's what it says, so good thing I got one solution. All right. What about this? This says that all of my answers should be no solution. All right, so I want you to pick at least 2 of these, write them down. I want you to solve them. And I want to make sure you agree with my answer. So then come on back, okay? All right, so example 4, if I subtract 5x from both sides, 5x from both sides, I end up getting negative 7 is equal to 3, which is not true. Therefore, I have no, that's supposed to be an N, no solution, no solution. All right, example 5, I'm going to use the distributive property. So 2 times 6x is 12x. 2 times negative 8 is minus 16. 4 times 3x is 12x. Oops. Oops, I thought I could erase that. All right, hold on. Sorry. Get my pen back. All right, so 4 times 3x is 12x minus 8. So then if I subtract 12x from both sides, I see that I'm going to get negative 16 is equal to negative 8. Is that true? No, it's not true. So we have no solutions. And then the last one, I'm going to combine like terms. So I have 3x plus 5x is 8x minus 6 is equal to 12 plus 8x. If I subtract 8x from both sides, I'm going to end up with negative 6 is equal to 12, which is not true. Therefore, no solution. All right, so I think that's all. Oh, infinitely many. So you guys pick 2, write them down, solve them, and come back and check your answer. I'm going to take a little coffee break. Delicious. All right, so look at this example 7. Do you notice that these equations match perfectly? If you ever get to this point in a problem where you go, oh, those are exactly the same, including the signs, then that means there's an infinite number of solutions or infinitely many solutions, okay? If you don't notice that and you canceled out your x's, you would still get 9 is equal to 9, which is true. All right, example 8, we're going to use the distributive property. So 2 times 8 is 16. 2 times negative 3x is negative 6x equals, we have 8 plus 6, not 8, 10 plus 6, which is 16. Negative 5 minus 1, negative 5 minus 1 is negative 6x. And then what do you notice? Everything matches exactly. Or even if I didn't notice that and I continued on, I would say 16 is equal to 16. Oh, that's true. Yes, infinitely many solutions. All right, and then look at example 9. So even though these are in the different orders, the signs match. For example, this fraction is a positive fraction, right? And this is a positive fraction, which means they are equal to each other. All right, what about the next number? The next number is a negative 11. Well, this is also a negative 11, which means these two equations match exactly. If I wanted to rewrite the second one and bring my positive fraction up to the front and bring my negative constant to the back, I would go, oh, well, look at that. They are exactly the same. So that means an infinite number or infinitely many solutions, okay? All right, so those are the type of problems that you're gonna practice today. I've left you some directions on Canvas. Follow those so that you can get all of your points today. You want to get all your 10 points today, so follow the directions and then answer those 5 questions I've proposed in Canvas. Everybody have a great day. If you need me, you know how to find me.